All right, so this lesson we're going to do this, we're going to spend 2 days on this topic. And so today we're just going to do the first page. And a lot of it is review. And so really, on this first example, everything we're doing, we've already done, except for like writing out the domain in a formal way. So the title is Equivalent Representations of Polynomial and Rational Functions. And so today, the equivalent representation is going to be factored form. And so we've definitely factored tons of time. We just haven't called it that every time. So on this first example, we're going to write this in factored form, which is an equivalent representation. And factored form is helpful whenever you need to find wholes and vertical asymptotes of the function and zeros. All right, so what x value would this function have a hole? Yes, ma'am. So we're looking for the common factors where the denominator completely cancels out. All right, what about a vertical asymptote? Good. And then a function is always undefined at the vertical asymptotes and the holes. And so if we give the domain, we eliminate where the function is undefined. So there's only two values that x cannot be, and then there are two values that would make you have 0 in the denominator. All right, and so we are going to give our domain in interval notation. And so we're going to start at negative infinity. And we're going to go all the way to what number, but we can't include that number. So all the way to, what do you guys think? -5. All right, and then we make sure we use a parenthesis so we don't include it. All right, and then we're going to pick back up on the other side of -5. So we do a -5 with another parenthesis. All right, and then we're going to go to all the way to what number, do you think? Yes. And then we'll pick back up on the other side of -2 and go all the way to infinity. Good job. All right, so I feel like that might be how the domain would be written on a multiple choice question. It's also possible it'll be written in words. So this is way easier to do in words. So if we were going to do this domain in words, we would say all real numbers except x equals -2 and x equals -5. Now whenever I guess one of the first days we did this, we wrote where the function was undefined. We would say x does not equal -2 and x does not equal -5. That we were finding the domain then. I just wasn't calling it that. All right, so that's pretty much the new stuff that's not super new. All right, let's look at example 3. This one we're going to do all the things. And so we're going to start off and write the equation in factored form. All right, so where are the zeros going to come from? The numerator or denominator? Numerator, yes. Can a function or can a number be a 0 and a whole? No, that cannot happen because the whole is not there. And so what is the only x value where there's a 0? -3, good. All right, what is the x value where there's a whole? Good. What about, there's 2 vertical asymptotes. Good. 0 and -5. So I'm going kind of fast. I feel like you guys know. I can tell some of you do. I might be going kind of fast. All right, so this says denominator doesn't cancel. And this is denominator and numerator, but we're going to say denominator and it cancels. Okay. When I do horizontal asymptotes, I always like to look at the unfactored version of the function because you need to know like the leading term and the largest exponent. So when we're doing horizontal asymptote, I like to take a look back at this guy. And what are the only two terms that matter? X squared and x. Sorry, x squared and x cubed. So the leading terms, all the other stuff doesn't matter for the horizontal asymptote. So what do you guys think for this one? Good. So the denominator is dominating because it has the larger degree. And so it's going to grow faster than the numerator, which is going to make it level off at 0. Okay. And then what are the 3 numbers that cannot be in your domain? 0, -5, and 4. So all the wholes and vertical asymptotes are where the function's undefined, so they are not in the domain. So I'm going to do interval notation again, just because it's a little bit more difficult than just writing it out in words. Now I would, unless I specified that I wanted it a certain way, I'll take it in words if that's how you would rather do it. Okay, so I'm going to graph what we can graph here, and then we're going to let the calculator help us out a little bit more. So I do know that there is a 0 when x is -3, so that's going to be an x-intercept. All right, and then I know that I have a hole at 4. I'm going to check real quick to see what the y value is. And so what I like to do when I find the y value is actually find the limit. So where would I plug that 4 in? I would plug it in for x, but I need to make sure that I take away the term that has the 4 in it, because that would make you have 0 over 0. So I'm going to put 4 in for all 3 of those x's. So this is going to be a super small number. 7/36 is very close to 0. So whenever I graph that, it's just going to be right above the x-axis. So just like a little hole right there, just floating. Okay, and then I know I have a vertical asymptote when y is 0, which, I'm sorry, when x is 0, which is the y-axis, and when x is -5. Right, and then I have a horizontal asymptote on the x-axis when y is 0. All right, so now when you guys do this on your own, when you do the function, I would definitely do alpha y equals for my fraction. And I think it's slightly easier just to type in the original function, but factored form will give you the same exact graph. Now the calculator is not perfect. So do you guys think that it actually stops right there, or it keeps going? Yeah, it's going to keep falling, and it's going to keep rising. The calculator just has issues. It's fine though. It's pretty good. Now this graph kind of messes with people's head a little bit because they think that you can't touch the horizontal asymptote, but right there at that 0, it does. And I've tried really hard not to say that it doesn't touch it. What I try to say is that it approaches it at the far ends. And so it is going to approach 0 as you go to the far left and far right. But in the kind of in the middle of the graph, it crosses it, and it's okay. It's fine. So what this graph has is a branch that looks something like this over here. And then here it kind of curves through. It does cross right there, and it's fine. And then as you go out to the far left, it's just going to get closer to 0. It's not going to touch it at the ends, but it can touch it in the middle. I know it's confusing. It's a little different than probably what you heard your Algebra 2 teacher say last year, and that's fine. For what they taught last year, what they told you was true. But sometimes in the middle of the graph, it can cross it, the horizontal asymptote. Never, ever, ever touches vertical asymptote, though. All right, any questions on this? Okay, the last 2 things we're going to do is we are going to be given the graph, and we're going to write the equation. So this really, I don't know, I feel like these, if you can do these, then you like have a really good understanding of all the parts of a rational function. And so when I look at this rational function, I need to pick out all the characteristics. One of those things is a 0. Does this one have a 0? Yes. At x equals 3. Right? Does this one have a hole? Yes. X equals 4. The vertical asymptote is x equals 2. And the horizontal asymptote is y equals -1. All right, so we are going to write this in factored form. So this guy is called f. So what factor gives you a 0 of 3? X minus 3. And if it's a 0, where does it need to go? On the top. Go ahead, numerator. All right. To get a whole of 4, we need x minus 4. Where do we need it? Nice. All right. And then a vertical asymptote of 2. Where do we need it? X minus 2 on the bottom. All right. And then the horizontal asymptote, is this one going to have, the way it's written, is it the horizontal asymptote going to be -1? What would it be? It would just be 1, right? Because this is going to be an x squared over an x squared. And so we divide and we would get 1. So how do we make it be -1? Yeah, just put negative.
Does it matter if you put it on top or bottom?
It doesn't. So let's just double check, because sometimes, I don't know, things get weird. Good. And then if you just want to double check, like there's no way to know for sure that the hole is there. Your calculator cannot graph a hole. I don't think it has like the pixels to be able to do it. It doesn't. But if we went to the table, oh gosh, hold on. I don't know why I'm so far down. Okay, now if we go to the table, we do see there's an error at 4, which there should be because there was a hole there. All right, this next one is a little bit more difficult. So anytime the horizontal asymptote works out like this one, it is slightly more difficult to get the right answer. But let's just go through and find all the things. Oops. So what factor would give you 0 as a vertical asymptote? Just x, good. Okay, I'm gonna type this in real quick, and then we'll decide if this is right. Oh, the reason I can't tell for sure is because the horizontal asymptote is 0. So when I look at this, the degree of the numerator is less than the denominator, so it is 0. That doesn't mean this is right. Okay, so look at that. Look at what your paper looks like. Doesn't look right. What does it look like? Yeah, it looks like a reflection. And so it's possible that that's all it is we just need that negative. But I want to show you a way to be sure. And this came up on one of them, maybe yesterday on the worksheet, one of the more challenging multiple choice questions. You had to pick it out, and there were several that looked like it was right. And I told you to look at where the hole was located and figure it out that way. And so what is it, if you were going to guess, what would you guess the y value is of this hole? 0.5 or 1/2. So let's say it is 1/2. So what is missing? There is like this little coefficient, I'm going to call a right now, that's missing. And so what I'm going to do is I'm going to take that a, I'm going to cancel out the x minus 2's and plug 2 in. I know this is weird. You may or may not even have to do this on the assignment, but I want you to see it just in case another time you might have to. Oh gosh, we only have 5 minutes. Sorry. All right. And so what I did is I'm basically doing the limit where I cancel this out, plug 2 in. What should I get? You should get the y value of the whole. So we get a over negative 2 equals 1/2. So what should a equal? Negative 1. Which is what we thought it was. Just double check. Yeah, and that fixed it. And we were pretty sure it was going to fix it anyway. Okay, so what questions do you guys have?